Okay, so we have a. Do you ever notice I start off every video with okay? Anyway, draw a square and it's inscribed and circumscribed circles. So we did that. So the purple square has an inscribed red circle and circumscribed orange circle. So find the ratio of the areas of the two circles. So to find area of a circle, that's pi r squared. So we want to find the radiuses of these two circles in terms of one of the radiuses. So I'll start with the smaller radius and just call that r. Alright, now since that purple square, since this red circle is inscribed in that purple square, that's going to form a right angle. So those purple lines are tangent to the circle. Alright, and same thing up here. So we just created a square. I know it's a square because all the angles are 90. Alright, I can assume this angle is 90 because it's a square, and then the two red right angles are 90 because they're tangent lines and radiuses. So that fourth angle has to be 90, so it's equal angular. Right, so since opposite angles are congruent, it's a parallelogram, and all the angles are congruent, so it's equal angular. And then consecutive angles are also congruent. Consecutive sides, right? These two sides are equal because they're both radiuses of the same circle. So these two segments would also be that. Okay? So this right here represents the area of the smaller red circle. So then, if you draw the radius of the bigger circle, like this, you could see that it's the diagonal of that square. So if you do special right triangles, that's a 45, 45, 90 triangle, or just the Pythagorean theorem with r, you get that radius of that big circle is root 2r. So the area of the big circle is pi times the radius squared, which is root 2r. So that simplifies to pi times 2r squared, or 2 pi r squared. So the ratio of these two would just be 2 to 1, or 1 to 2, depending on how you do it. 2 pi r squared divided by pi r squared just comes out to be 2 to 1. So the answer is 2 to 1 or 1 to 2, depending on the order.